The number of our project is 21082. The title of our project is Design of a Separation Process for Wayuli Resin. Our team is sponsored by Bridgestone, and the team members are Shivali Naran, Chris Rodriguez, Pablo Quero, and Jose Montañez. All of our team members are majoring in chemical engineering. Wayuli resin is a byproduct of the extraction process of rubber from the Wayuli plant. We can see this by this representation. First, we start with the Wayuli plant. The Wayuli plant goes through a process to produce Wayuli rubber, which is high-weight molecular rubber, which is used by Bridgestone to make tires. The byproduct of this process is an acetone extract, which contains Wayuli resin. The composition of the Wayuli resin is shown in this table. The compounds that we're interested in are terpenes and fatty acids because they have a high value on the market. The terpene that we will be separating is alpha-pinene, and the fatty acid is linolenic, which has a 10 to 15% by weight of the Wayuli resin. The objective of our project is to develop a process which produces two streams with at least a 90% mole purity. One stream has a 90% mole purity of the terpene compound alpha-pinene, and the other stream has a 90% mole purity of the fatty acid compound linolenic. Next, we talk about the process flow diagram of our separation process to see how this objective was accomplished.
So below is the first section for our process flow diagram. It starts with the input of Wayuli resin, which is then sent to a flash drum. This flash drum separates out its components, and the bottom stream is then sent to a distillation column, where it's then separated into a top stream of acetone, isoprene, and terpene, and a bottom stream of fatty acid and terpenoid. The tops for the flash drum are then sent to a condenser, and from there they're sent to another distillation column where it produces a top stream of isoprene and acetone and a bottom stream of terpene-rich stream. Below is the second part for our process flow diagram, and we'll start at the bottom. So the input for this distillation column is the fatty acid and terpenoid rich stream. The distillation column separates it out into a top product of terpenoids and fatty acid mixture and a bottom stream of a rich in fatty acid. This top distillation column has an input of acetone, isoprene, and terpene. It separates out this stream into a top stream of predominantly isoprene and acetone, and a terpene-rich bottom stream, which is then sent on to a mixer where it's mixed with the other terpene-rich stream from the previous section. And this gives us a terpene-rich stream of about 92 mole percent. So the results, our process has 4 final streams, that being acetone and isoprene mixture and a fatty acid and terpenoid mixture. And the other 2 streams are 90% mole pure fatty acid and a 92 mole percent terpene stream. And this process allowed us to achieve our goal of getting at least a 90% pure terpene rich stream and a 90% pure fatty acid stream.
So for the economic impact of our process, we simulated the economics side of our process on Aspen. We found that the total capital cost was about $4.6 million. Total operating cost per year was about $1.3 million. And the utilities cost per year was about $36,000. Some of the hazards that we have to keep in mind on the economic aspect of it was the cost of farming, which we found to be to have been rising the past 4 years about 7.84%. The cost of acetone also has a high risk of fluctuating throughout the year. In just the last month, we saw that the cost of acetone per metric ton decreased about $1,000, which shows the volatility of this chemical that is important to our process. We can mitigate these by monitoring very closely the price fluctuations and readjusting and reevaluating our process after that point if needed. The environmental impact would be small for our process regardless, due to the amount of raw material entering the system, which is a low amount. However, there are hazards that we have to keep in mind, one being climate change and how it can affect our process the worse it gets. Arizona is in a desert terrain, so climate change can affect the growing process of Waiuli so that the plant may not survive under the changing weather conditions. Also, the potential pump leakage could be dangerous in the facility due to the presence of chemicals like acetone. For some of our utilities, we found the electricity to be about 52 kilowatts, and our cooling water was found to be about 11 gallons per hour. Our process is continuous, which will save us both water and electricity by not having to use energy and use more water to start up the process every day. This is both a decision we made to help impact the environment in a positive way and also bring our cost down.
So in conclusion, Bridgestone is using rubber, unlike other companies who still have man-made rubber. From this, when they make our rubber, to extract the rubber from a Waiule plant, there's a leftover resin that we do not want to throw away because that is waste for the products. In this resin, you basically find the terpenes and the fatty acids. And we want the 90% purity of terpenes because terpenes can be resold and used in industry to help with the scents of the different products, such as perfumes and cleaning products. Our process is water, and there's not a huge environmental and economic impacts, and this will basically help in the whole scheme of what's the most efficient way to separate resin. Thank you for listening to our presentation, and have a good day.